design tools, right? These allow us to analyze thousands of shapes and focus in on that low boom shape. So NASA is actually confident that with this technology, we have the tools and the technology to build, a viable supersonic aircraft. So I do want to talk a little bit about the sonic boom problem. Right, for any aircraft flying faster than Mach 1.2 or 900 miles an hour, there's a sonic boom that can be heard on the ground, and it follows the aircraft for its entire flight path. And it's a common misconception. It's not a one-time event. So it's about up to a 50-mile wide path everywhere the airplane flies. So as a result, this noise is experienced on the ground as a short duration sound, or what we call a sonic boom. So based on what we've learned, right, we want to, the next step is to fly a supersonic demonstrator. And if time permits, right, I'm going to talk, if we don't have too many questions, if there aren't any questions, I can cover, details on the vehicle, but certainly we want to take your questions, not just what I want to talk about. So when the Concorde first entered service, right, it was using 1950s and 60s technologies, right, which were very impressive, but they were not designed for a low sonic boom. And like I talked about before, those modern design tools allow for aircraft shaping and tailoring of the shock waves so that we get a much quieter sound on the ground. And we've done a lot of computer simulation and wind tunnel testing to estimate how much softer this sound is. And I did want to highlight that a lot of this wind tunnel testing happens right here in Cleveland. We've done 5 or 6 wind tunnel tests in the 8x6 supersonic wind tunnel, which is one of our historic test facilities that first